So, hi everyone, my name is Sharon Azulay. I'm the CEO of Plexistor. I'll go over a couple of use cases. I'll try to keep it really, really short and simple. The first use case is a SQL database. In this case, it's a customer who's running a MySQL database. The data kept increasing, and the number of customers actually approaching internal users in this case, running queries on the database also increased over time, is slowly drifting, the amount of data is slowly increasing, and the performance is slowly going down. And he was looking for a solution that didn't require him to shard the data. This is usually what most customers are doing, sharding the data, breaking the data into pieces, running each piece on a different database. You need to modify your application to actually support it. That's not a simple task by itself. And what he did was very simple. He was actually downloading Plexistor, installed the Plexistor solution, and almost immediately gained 2x performance improvement with its database. And he didn't have to shard the data. He didn't need to do anything to the MySQL database. Immediately, he was able to extend the life of the MySQL deployment. And actually, what he did, it actually gave him time to start working on a better solution. He can't really avoid eventually data sharding. He can't really avoid eventually buying a much bigger system, okay? Because there is, again, a limit to what Plexistor can do. But it definitely gave him enough time to come up with a better solution, and he can run probably the system for another few more years before taking a decision going forward.
Are there any limitations around capacity? Like how big can this file system get at the moment?
So there is a direct correlation between the primary tier and the secondary tier, the memory tier and the storage tier. Right now, the ratio is 1 to 12. So let's say that you need a 2 terabyte storage divided by 12, and that's going to be the size of the T1. This is a rule of thumb. Okay? This is just out of experiments that we've done. It doesn't mean that this is going to be the case with your data set. It depends on the kind of queries you're going to do. It can depend on the application, on many other parameters. And the only way to actually understand that is by analyzing the system. Before installing, we actually have a tool that monitors your behavior, the application behavior, and then we can determine, oh, we need that amount of primary tier and that amount of secondary tier. At the end of the day, the sum of both needs to meet your data set size.
But there's no limitation on that at the moment. It can grow to petabytes, for example.
It cannot go to petabytes.
Yeah,
it's definitely in the range of terabytes.
So we're talking about as per node, right? Sure. To begin with. So per node, our basic assumption that you don't need more than several terabytes per node. I mean, that's usually what we see with the application servers. Mm-hmm. Theoretically, with the 3D crosspoint being 6 terabytes per server, even if you follow the rule of thumb, I mean, you can have 70 terabytes per node or something like that. If you want, you can buy a 4-socket machine and have, more than, double that amount. But we don't really see, I think, usage for that. At that time, a third tier that's off the node would make more sense.
In most cases, the working set is a very small percentage out of the data set. It's not the entire data set. Okay?
I have a question there where
Sure.
you say it was the same hardware and no application modification, which is great.
Right.
We were talking before about the need for NVDIMMs in order to protect against node failure.
Correct.
So in this case, it sounds like they didn't actually go down that path.
They didn't use NVDIMM. He was actually just testing the system, and what he did was splitting the memory by half. Half of the memory went to the application, and half of the memory went to Plexistor.
Okay.
So actually, if you think about it, it's funny. We actually reduced the amount of memory available to the application and still gained twice the performance. That's
okay.
But eventually, I mean, he's still testing the system. In this case, tweaking
He'll
the
need to deploy
configuration files, trying to get more out of 2, more than I think 2.5 actually, but more than 2x in this case.
Okay, but
right.
in order to have a production-ready system,
NVDIMM is the only way to do it.
Okay.
Right.
That's the only way to do it. Another use case, in this case, it's a NoSQL. The victim was MongoDB. Same scenario, exactly the same scenario. The amount of data slowly increases. You need to deal with more queries per second. And the way for MongoDB, again, is a sharding mechanism. The complexity of managing a sharded cluster is very high, CapEx and OpEx, actually. It's not just buying more machines. You need to spend time tuning and managing those servers. And this is something that was very difficult for this customer to do. They've decided to install Plexistor, and they actually been able to maintain the same level of operational expenditure, the same number of servers, while extending the capacity, the performance, and the efficiency of the entire cluster. So pretty much the same benefit, different applications. In this case, is capable of running completely on DRAM. It doesn't really need NVDIM, and the reason is that Mongo is maintaining its own replication set. The HA is done at the application level. Okay, so the only thing this guy needed is a pure software solution. He doesn't need to purchase non-volatile DIMMs. Okay, we have other use cases. I'm not going to go through all of them, but RabbitMQ, which is a message queue, very sensitive to storage latency. And we've been able to show, while maintaining persistency, again, with NVDIMs, an increased performance, KVM virtualization. By providing high-performance storage, we've been able to increase the VM density. Depends, again, on your application and your specific use case. There is no magic number. We can't say that it's 5 times, 10 times, 20 times. Depends on the kind of VMs and the kind of load that you are putting on the system. But you can increase the VM density by providing a much faster storage technology. And the same thing for HDFS. With HDFS, it's actually interesting. You've got the data node, you've got the name node. The name node is the metadata server, quote unquote, that knows where data is actually placed on the data servers. This name node is using a lot of small writes, small reads, and this is why a very fast storage is an excellent solution for a name node. So the case of a name node is actually very interesting because it's directly impacting the performance of HBase and Solar, both of them running on top of HDFS, doing a lot of random access to the data. And this is, again, where we can shine. Any questions? I think actually this is the last one.
Thank you.
Thank you.
I think there's a huge amount of detail in what you presented.
What?
I was going to back you.
There's some very interesting pieces about how you would apply that technology compared to others and understand exactly how you'd fit it in. So we haven't got the time to talk about it now, but I don't know whether you're coming out this evening with us, but it'd be interesting to understand how this compares to things like other caching products and various other things when you're talking to customers. And you know, that's probably, I think, probably the most difficult bit for
Absolutely, and
work out probably.
And you raised a very interesting comment. I'll take another minute on that if it's okay with you guys. We are being kept compared to a caching technology. And there is a fundamental difference between caching and storage. We all know that. The fact that we're using memory as a storage doesn't mean that the solution is caching. Caching means that, it's an intermediate storage device. It means that at the end of the day, we need to flush it eventually at some point back to a persistent storage. When you're using NVDIM, non-volatile DIMM technology, that's not the case. We'll never move a data from the primary tier to the secondary tier for any reason other than we don't have enough space on the primary tier, or the data became really, really cold and we don't need it, okay? So this is really the basic fundamental difference between caching and storage. And in the cases, by the way, where you are massively read, we can show very little benefit comparing to cache technology. Okay, those are the cases where if you have a cache technology, that's absolutely fine, keep it, don't change it, okay? We are more relevant when there is a mixed workload of read and writes, and mostly small writes. This is not a magic solution, it doesn't fit all use cases. So I'm trying to be very clear where it can fit, okay?